So here we're going to talk about relays, and we're going to show you today how you can test one using a multimeter. Now, if you recall, relays allow one circuit to control another circuit. In a lot of applications, this is used to allow a low amperage circuit to control a high amperage circuit, as we might have with a starter relay or maybe a relay that runs a cooling fan. The control side of it might be controlled by the computer, use relatively low amperage, and it will allow the relay to control the higher amperage fan circuit. A relay can also be used to allow any circuit to control another one, and one example might be for fog lamps. Here in Pennsylvania, it is illegal for fog lamps to be illuminated when the vehicle is on high beams. If somebody adds fog lamps, one way they can ensure that it meets this requirement is to wire a relay in there. They can use the normally closed side of the relay and run the fog lamps through there, and run the high beams to the control side of the relay. When the high beams are turned on, that is going to open up the normally closed circuit and interrupt the flow of current to the high beam or to the fog lamps. Relays come in a few different sizes. This is a very common square type one. It might be square but have a metal case. As mentioned in a previous video, they will typically have 4 to 5 terminals. There are smaller size relays like we see here, sometimes with smaller terminals. And they come in different voltages. This happens to be a 24 volt relay, and we will do some testing on that. What's happening inside a relay, here's a schematic, and you can see that 85 and 86, they are our control side, or that is where the coil is going to be that we're going to energize to turn that relay on or off. The other side, 30, is typically where the power will come in, and it will either go out through 87A, which is going to be our normally closed until the solenoids or until the relay is energized, and then it will connect to 87, which is normally open and closes when that solenoid is energized. What you have occurring inside the relay is you'll have this, the cover was removed from this one. You have this coil of wire, which when electricity flows through it becomes electromagnet, and it will move this breaker points to make the connection between either the 87A to the 87 and allow that relay to energize what it's controlling. So here we have a relay, and we're going to start or begin to test it by ohming out the control side of the circuit. If you remember, that is terminals 86 and 85. So we'll set our multimeter to ohms. We'll take our clamps. A lot of relays have the terminals labeled, so you just have to find the correct terminals. It is also handy when the relay includes its own schematic or picture on it. So we're going to go across 85 and 86, and what we're looking for is some level of resistance. We don't want it to be 0, that would indicate a short. We don't want it to be excessively high or out of limits, that would indicate an open. You can see right now this relay reads at 93.2 ohms. So that would be the coil. That tells us that there is a continuity path through that coil, and in most cases that coil is good. Now that doesn't fully test our relay. We still need to test the other terminals, the 87, 87A, and 30 terminals, which we will do next. Before I move on to that, I mentioned we have a 24 volt relay. So let's compare the resistance in our 24 volt coil compared to the one we just tested, which was a 12 volt relay. So we're going to clamp on the same terminals. And you'll notice that our meter reads 0.426, but it's K ohms or kilo ohms. So that would be actually 426 ohms, which is considerably more than what we saw with our 12 volt, which would be expected. You would expect higher resistance on a 24 volts relay compared to a 12 volt. Let's go back to our original relay that we're testing. We mentioned that terminal 30 to 87A is normally closed, so right now there should be a continuity path between them. So we will clip onto 30 with one of our leads, doesn't matter which, and we will connect to 87A with the other one. And we should see relatively low resistance when we do that. And here you can see our resistance, and I can get it to maintain connection here. Drops down to 0 or 0.1, 0.2 ohms, very low number. So that indicates that path of the relay is good. Now to test this relay any further, we need to energize it. So we have a 12 volt battery here, 2 jumper wires, And we're going to hook that up to the 85 and 86 to now energize our relay. When that occurs, we should see that 87A and 30 that we just tested, it should go from continuity to open. So I'll even clip these leads on here so you can hopefully see that change in the meter. You might also notice that you'll be able to hear this. A lot of times the relay, you'll hear an audible click when it connects. So we have one lead energized. We're going to energize the other side. There it clicked. And you can see our meter just changed to OL. If I disconnect it, it closes again. I see that we're not quite making connection between the 87A and the 30. Let's make sure we can do that. Sorry about that. Let's try this again. All right. There's our connection between 87A and 30. We'll connect to our relay. It clicked and opened, and it changed to our limits. If I de-energize it, it will go back to making connection. While it is energized, we can now test for continuity between the 30 and the 87. So we'll do that. And we should have low resistance, 0.1 or 0.2 ohms like we saw before. Here we have that. If I disconnect my battery, it switches to out of limits. So this would appear to be a good relay. That it is closing. The normally open is making a closed connection when we energize it. It's opening when it's not. And the normally closed is doing the opposite. It has a path for continuity when it is not de-energized, and it opens once we energize the relay. Remember, you can test it with an ohm meter, but you will need to have a voltage source to be able to energize that relay to test the other connections.